Good morning friends. So here we are going to see the various tests on fine aggregates. In the first one we are going to see the sieve analysis. We are going to see sieve analysis. We will list specific gravity, bulking, moisture content. 4 tests is there. Very important from your exam point of view. Lot of times the test on fine aggregate have been asked. Okay. So here, if I read all these things, you will not understand. First, I will go to the diagram. So there I will explain first and later on we are going to come back here. Here. Okay. So can you see this diagram clearly? This is called as sieve. What I was explaining in the previous videos, that a particular opening is there, no? So this is the opening. So this type of thing is also present in kitchen also, no? To sieve the atta. Okay. So in the same case, to sieve to sieve the aggregate or sand, we are using this sieve. Okay. On this there is some numbers generally written. When you come to the college and you visit the BMT lab, you can easily understand what are these. Okay. So here the sieve size is mentioned. If the sieve size is 4.75, that means what? This gap size is 4.75. This gap is 4.75. What is happening here? When you see this one, the bigger particles which have size more than 4.75 will retain here. The particles which have size less than 4.75 will pass. I hope you have understood this point. Okay. If the sieve size is 4.75, when you conduct the sieve analysis, the particles whose size is more than 4.75 will retain, and particles whose size is less than this sieve size will pass. You can see here, no, in this diagram, if it is a 4.75 sieve, I am just giving the example. The particles which have retained means what? Not passing, or retained means what? Their size is more, no? Their size is more than this opening, so that is why they are not passing. The particle size which have less, no? So they have passed. Maybe next sieve maybe 2.36, maybe next sieve maybe 1.12, maybe next sieve maybe 900 micron. Okay. So 1 micron is equal to 1 divided by 1000 mm. 1 divided by 1000 mm. That's all. Okay. 900 micron, 600 micron. Okay. 150 micron. Okay. So this may be pan. Pan means no opening, only dust will come and collect. Okay. If you see this diagram, bigger particles are at the top. The smaller particles are passing. Smaller particles are passing. Smaller particles of size less than this sieve opening. Particle size less than this sieve opening are passing. More than sieve opening, they are retained here only. So here the bigger sieves are kept at the top, next to smaller sieves. See, 4.75 sieve, 2.36 means what? Here the opening size is still less. I hope you have cleared. So it is always arranged such that the bigger opening or bigger sieves at the top, smallest opening or the smallest sieve at the bottom. Okay, smallest sieve at the bottom. This is pan. In sieve analysis, what you are doing, you are taking 1 kg, 10 kg, you are putting at the top of the bigger sieve, and you are shaking this total setup. Like with hand or with mechanical vibration, you are shaking. In that process, the particles will start passing through these sieves. Okay. So the particles will go and pass through different sieves. Smallest will pass through all sieves. Yes, do you agree? Smallest particles, finest particle will pass through all the sieves and comes and deposit here, pan. A little bit bigger will come and will not pass through, will retain here, will not pass through and retain here. still some more bigger will pass through here, will retain here, and the same procedure will continue such that you are getting biggest particles here, smallest particles here. Okay, and in the process you are doing what? You are separating the aggregates into different sizes. So 1 kg or 1000 grams of sample, in that you may get this 4.75 size 600 grams, 200 grams, 100 grams, 80 grams, okay, 50 grams, 10 grams, like this I am giving the example. Okay, so in the same way you are putting the aggregates, you are shaking such that you are separating the particles of different sizes, later what you are going to do, you are taking this sieve and taking the weight of this aggregate, maybe w1, and you are taking this one and you are weighing the aggregates present here, w2, you are taking this one, aggregates present here. Okay, this is total. How you have done putting the aggregates, shaking and taking the weight later? What do you mean by this? W1 is weight retained on 4.75, W2 is weight retained on 2.36, W3 weight retained on this sieve. Okay, what is happen? 1000 minus this W1, what is give, what it will give? W1 is weight retained, yes, on this size. 1000 minus W1, what it will give? Total sample is 1000, no? W1 is the weight retained, no? So 1000 minus W1 will be weight passing. W1 is weight retained, 1000 minus W1 is weight passing, okay. So W1 weight retained, this total is 1000 minus W2, okay, same way. Now W1 divided by 1000 into 100, what is this? Into 100, weight retained on the sieve to the total weight into 100 is nothing but percentage. How you have done, no? For example, 450 marks out of 800 marks into 100, okay, like that. Okay, same way weight retained divided by the total weight into 100 will give percentage weight retained on this sieve. Okay, 100 minus this value, percentage, 100 minus this percentage will give percentage passing. Simple, no? Simple, very simple. W1 divided by total weight into 100 is nothing but percentage retained. 100 minus this total value, percentage passing. Simple. One is weight portion, another is percentage portion. In the next table you are going to see. This process is clear. Sieve analysis, what you have done? Sieve analysis, you have arranged the bigger size at the top, smaller size, given sample taken, put it on the top, mechanical shaker, separating the particles, taking the each pan or each sieve and taking the weight. Similarly you have done, and the table will come for the calculation. This is called as sieve analysis. Main aim of this experiment is conducting the sieve analysis is separating a given fraction into different separate fractions. You are getting what? 2.36 fraction, 1.16 fraction, 500 micron fraction, like that you are separating the fractions. Okay, now it is clear. Sieve analysis, I hope I have explained clearly. Okay, so here in the next diagram you will see this is another more photos I have done. Sieve setup. Okay, sieve setup, mechanical vibration. Okay, here also you can see mechanical vibration you can get. Okay, so by putting the aggregates at the top, you will switch on the machine and it will vibrate. Okay, Here also you can see sieves stacked on the shaker. This is called as a shaking machine. Shaking machine. Okay. So here a lot of photos I have put for easy understanding for everything. Okay. So sieves setting. This is the table I have explained. Okay. Now what you have done is, so 10 mm at the topmost. You see this diagram. 10 mm at the topmost. Okay. 4.75 like this you have arranged. No, you have arranged. First column is IS sieve, Indian Standard Sieve size. So where it is written on the sieve size, on that sieve it is written like this: 10 mm, 4.75, 2.36, 1.18, 600 micron, 300 micron, 150 micron. So at the bottom most you are getting what? Pan. You are getting the pan. What is happening here? After conducting the sieve, what is the weight retained? I said no, on the top what you have retained, W1, W2, W3, these are all W1s, W1, W2, W3, like this. So whatever weight retained, no, that you have calculated, that you have weighed and written. Okay, second column, that is what? Weight retained, weight retained. So on the top, nothing is retained, almost all passed. On the second sieve, this much weight is retained, third weight is retained, so like that it is retained. When you add all those things, you are getting 1 kg or 1000 grams, 1000 grams. Okay. Third column, percentage weight retained. Percentage, how you are getting? This W1 divided by 1000 into 100. This W1 divided by 1000 into 100, this value. If you take this one, W3 divided by this value into 100, you will get this much percentage, this much percentage. I hope it is clear how the third column is done. Percentage weight written. This values divided by this total into 100 will give you this one. This will give this. Cumulative retained, cumulative percentage retained. So 0 you have written here, 0 plus this you have written here, this plus this you have written here, this plus this you have written here, this plus this you have written. So at the end, for final you are getting 100. Okay, 100. So how you are getting passing? 100 minus this, no? Yes, I have explained, no? This is percentage retained, percentage passing. If you add both, then you will get 100 number, no? So 100 minus this, 100 minus this column will give percentage passing, percentage weight passing. Okay. So 100 minus 0, this value, 100 minus this value, 100 minus this value, like that. So 4 columns: sieve size, weight retained, percentage weight retained, cumulative percentage weight retained, weight of percentage passing. Okay. Now what is happening here? There is one small calculation, So what is happening here? What is happening here? If you add all these things, which column? Cumulative percentage retained in that sieve test. If you add all these things, you will get one number. And that number is written here. If you divide this number by 100, you will get one value. So this value is nothing but fineness modulus. This is value is nothing but fineness modulus. Okay. Now you understand fineness modulus. Let us say another, for one it is come 3.5. Another value if it is 3.8. You understand that smaller the value, finer the sand. Bigger the value, coarser the sand. Finer means small particles are more. Coarser means large particles are more. What do you mean by fineness modulus? You have a value of cumulative percentage retained. You add all those things, and divide by 100, you will get that number. This number is nothing but fineness modulus. Smaller the fineness modulus means what? Finer the sand. Bigger the fineness modulus, coarser the sand. Coarser is the sand. So this table is clear. Sieve analysis how you have done. Okay. Yes. So we will go back to that theory portion. So here in the theory, what we have discussed now just now, okay, that only explained. Sieve analysis is conducted to determine the particle size distribution. Yes, we have separate particles we will get at the later stage in a given sample of aggregates, which we call it as grading or gradation. Sieve analysis, which will separate the different particles. Okay, we call it as grading. Call it as graded. Here, the particle size distribution is an important physical property, very important physical property, which affects the properties of concrete, later. Okay, so sieve analysis is done to separate the different particle sizes, and this property is very important, which will decide the concrete property. Okay, here sieve analysis is a simple test considering sieving a measured quantity of material through successively smaller sieves. We have seen no smaller sieves at the bottom, bigger sieves at the top level. So what you are doing, the weight retained on each sieve is expressed as percentage. So in the third column, what you have seen, percentage weight retained, no percentage weight retained. So that line is, this line is explaining that point. Okay, so the weight retained on each sieve is expressed as percentage. How? W1 divided by 1000 is nothing but given total weight. Okay, that's why 1000 I have written. 1000 into 100, this will give what? Percentage. Okay, at the end you are getting what? Fineness modulus. What is that fineness modulus? It is obtained by adding cumulative percentage weight. Fifth column, no, we have seen, no, that column cumulative percentage weight. You are adding those all values, and what you are doing, you are dividing it by 100. We have seen in the table. Fineness modulus is one empirical factor which will tell whether it is a coarser or whether it is a finer. How you are getting? Adding the cumulative percentage of all the aggregates and dividing it by 100. Okay, here the procedure is explained, what we have discussed now. Taking 1 kg of sample dry fine aggregate, choose the appropriate sieve set as per IS code 383. So in the table, first column was there, no, sieve size 10 mm, 4.75 mm. So those are sieve set according to this. Okay, so what is there? What is happening? The weighed sample is placed on the largest sieve at the top. Means what? First you are pouring the sample total 1 kg at the top. Sieving is done mechanically or manually. Means what? Machine also you can use, or by hand also you can conduct the sieve analysis. Sieving is done how? By giving various motions in different direction. Means what? That sieve set is there, no, by shaking in horizontal direction in the all the xy direction, such that material is kept moving over the sieve. Means what? On that sieve the materials will start mixing and start falling at the bottom. Sieve analysis. So here general, the sieving should be done more than 2 minutes, means not less than 2 minutes. Okay, next, the fraction of the sample passes through each sieve is placed on the next successive sieve and sieving is done. Means what? Bigger particles, smaller particle, still smaller particle will start passing through this one. That's the meaning. Okay, on the completion of the sieving, material retained, very important, on completion of the sieving, material retained on each sieve is weighed and recorded. That is W1s, W2, W3. Okay, all individual sieves are taken and weighed.